Geometric series tells a series of the form the summation of a over b all raised to the power n from n equals to 0 to infinity, where arrow is equals to a over b, x the common ratio if the absolute value of arrow is greater or equals to 1, then the series diverges. If absolute value of arrow is less than 1, then the series converges. So this is the geometric series types. Geometric series is of this form. This is a geometric series where arrow is equals to a over b, which is a common ratio arrow. Now, if the absolute value of arrow is greater than 1, then the series diverges. But if the absolute value of arrow is less than 1, then the series converges. So if we are given a geometric series, we just need to find the common ratio. If the absolute value of the common ratio is greater than 1, it diverges, but if the absolute value of the common ratio is less than 1, it converges. Now let's take some examples. Example 1. Show whether the series, the summation of 1 over 2 raised to the power n from n equals to 0 to infinity diverge or converge. So we're going to show whether the series diverge or converge. So the first thing we need to take note of is to determine whether or not it is a geometric series. Now, a geometric series have the form, the summation from n equals to 0 to infinity of a over b all raised to the power of n. Now, these two series, are they the same form? Now consider the series given in the question. The summation from n equals to 0 to infinity of 1 over 2n. Now this is equals to the summation from n equals to 0 to infinity of 1 raised to the power n over 2 raised to the power n. Of course, 1 raised to the power n is equals to 1. They are the same thing. Now this is equals to the summation from n is equals to 0 to infinity of 1 over 2 all raised to the power n. Now we have this form, the geometric series form. The geometric series form is the summation from n equals to 0 to infinity of a over b all raised to the power of m. Now both are similar, and from here we can say that a over b is 1 over 2. Yes, a over b is equals to 1 over 2. This is so true. Now remember that from the definition of the geometric series steps, arrow is equals to a over b. That is the common ratio. The common ratio is a over b, which is arrow. So arrow is equals to a over b is equals to 1 over 2. For the common ratio, 1 over 2. And 1 over 2 is equals to 0.5. Now, the absolute value of arrow is equals to the absolute value of 0.5. What is the absolute value of 0.5? You know, when there is absolute value, it means the positive part of the number. If it's negative, throw away the negative sign and just write it out as 0.5. But this is positive, so just put it as that. So the absolute value of arrow is actually 0.5. Now 0.5, is it greater than 1 or less than 1? Obviously, it's less than 1. Now, from the condition given, if the absolute value of arrow is less than 1, then the series converge. So we can rightly say that the series converges because the absolute value of arrow is less than 1. So it's quite easy. First of all, you need to make sure that it has the form of a geometric series test. That's what we just did here. We converted it from the way it is and ensure it looked like that of a geometric series. It's a geometric series because it's a all over b all raised to the power of n. And a over b is the same as arrow. Arrow is equal to a over b, which is 1 over 2, and 1 over 2 is 0.5. And hence, since 0.5 is less than 1, the series converge. Example 2. show whether the series, which is the summation from n equals to 0 to infinity of 3 all over 2 all raised to the power of n diverges or converges. So solution. Now the question is it a geometric series? Of course it is, because it is of this form, the summation from n equals to 0 to infinity of a over b. So if we have any series that is of this form, it is a geometric series. So this particular series, which is the summation from n is equals to 0 to infinity of 3 over 2, is a geometric series. Now, arrow is equals to 3 over 2. Now, the absolute value of arrow is equals to the absolute value of 3 over 2. And this gives us 3 over 2, also a positive number. Now, 3 over 2 is the same thing as 1.5, which is greater than 1. And from the condition given above, if the absolute value of arrow is greater than 1, then the series diverges. So the series diverges, so we can write that, hence it diverges. So this series diverges because arrow, which is 3 over 2, the absolute value of 8 is greater than 1, and hence it diverges. Consider example 3. Example 3, show whether the series is the summation from n is equals to 0 to infinity of 5 into 1.0005 raised to the power n diverges or converges. So the first step, we need to check whether or not it is a geometric series. Now remember that a geometric series has the form, the summation from n is equals to 0 to infinity of a over b raised to the power n. Now can we get this from here? Of course. Now consider this. The summation from n is equals to 0 to infinity of 5 into 1.0005 all raised to the power n is equals to 5 summation to infinity n equals to 0 into 1.0005 all raised to the power n. So we can take this 5 out. So since this power doesn't affect 5, so we can proceed. This equals to 5, the summation from n equals to 0 to infinity of 1.0005 over 10,000 all over n. So arrow is equals to 1.0005 over 10,000, and the absolute value of arrow is equals to, if you divide this, obviously it will still give us back 1.0005, and this is equals to 1.0005, which is greater than 1. Hence the series diverges. So consider example 4. Show whether the series is summation from n equals to 0 to infinity of minus 1 over 2 raised to the power n converges or diverges. So the first step, we need to check whether this series is a geometric series. A geometric series has the form n equals to 0 to infinity of a over b all raised to the power n, and is the same form where a over b is equals to minus 1 over 2. Hence, arrow is equals to minus 1 over 2. This is equals to minus 0.5. Now the absolute value of arrow is equals to the absolute value of minus 0.5, and the absolute value of minus 0.5 is equals to 0.5, and this is less than 1. Hence, the series converges. So if you want to learn more about the convergence of a series, whether it's geometric or any other form, feel free to ask me on WhatsApp. Meanwhile, subscribe to this channel, like and share this video. Bye.